Beneath the waves, in the depths of the ocean, lies a world shrouded in mystery. A world where sunlight cannot penetrate, and life seems to cling to the shadows. But what if I told you that in this dark abyss, scientists have discovered a remarkable phenomenon, a source of oxygen that defies everything we thought we knew about how life sustains itself? Welcome to the story of dark oxygen. Mind yourself, as this is not related to dark matter or anything. It's pure oxygen. Then why are we calling it dark? Let's see in detail. Our journey begins in the Clarion-Clipperton zone, a vast expanse of the Pacific Ocean, approximately 4,000 meters, about 13,000 feet below the surface. This area, rich in polymetallic nodules, has long been the focus of scientific research and more recently, commercial interest for deep-sea mining. If you go below the ocean in the Clipperton Fracture Zone, you'll find these potato-sized rocks, composed of valuable metals like manganese, cobalt, nickel, have been subject to intrigue for years. But what lies beneath their surface is far more astonishing than anyone could have imagined. As scientists began to explore this remote region, they were not just searching for minerals, they were delving into the very foundation of life itself. In 2013, a team led by researcher Andrew Sweetman embarked on a mission to measure oxygen levels in this secluded environment. What they found was nothing short of extraordinary. Instead of observing the expected decline in oxygen levels as they descended deeper, they witnessed an unexpected rise. At first, Sweetman thought it was a malfunction of their measuring device. After multiple recalibrations and repeated experiments over the years, the result remained consistent. Oxygen levels were increasing, not decreasing. This was a shocking revelation that would challenge long-held beliefs about how oxygen is produced in the ocean. This revelation led the researchers to a groundbreaking hypothesis. The polymetallic nodules were generating oxygen through a process called electrolysis. But how could this be possible in an environment devoid of light? To understand this, we need to delve into the science of electrolysis. Electrolysis is a process where an electric current splits water into two components, hydrogen and oxygen. The team discovered that these nodules acted like natural batteries, producing a small electric charge capable of driving this reaction. But what exactly is happening at a molecular level? In the laboratory tests, the nodules exhibited voltages of up to 0.95 volts, suggesting they could indeed function as geobatteries. This was a revelation that could change our understanding of life in the deep ocean. The researchers proposed that the unique mineral composition of these nodules might create conditions favorable for electrolysis, allowing oxygen to be produced in a place where we least expected. The implications of the discovery are profound. For decades, scientists believed that the primary source of oxygen on Earth came from photosynthetic organisms, plants and algae that thrive in sunlight. But dark oxygen challenges this notion. If these nodules can produce oxygen independently of photosynthesis, it opens up a new avenue for understanding how life could have originated on our planet. Could this process have been the spark that ignited life in the early Earth? And could similar processes be occurring on other celestial bodies like Europa or Enceladus, where conditions may support life? The discovery of dark oxygen not only reshapes our understanding of marine ecosystem, but also expands the possibilities for life beyond our planet. As the world turns its gaze towards the potential reaches of the deep sea, the discovery of dark oxygen raises critical questions about the environmental impact of deep-sea mining. The Clarion-Clipperton zone is a prime target for mining companies seeking valuable resources. Experts warn that Mining these nodules could disrupt delicate ecosystems that rely on oxygen produced by these natural processes. A coalition of over 800 marine scientists from 44 countries has already called for a halt to deep-sea mining until further studies can assess the potential risks. The stakes are high, and the balance between resource extraction and ecological preservation hangs in the balance. The journey of understanding dark oxygen is far from over. Researchers like Sweetman emphasize the need for further investigation into how this process works and its significance for marine ecosystems. The scientific community is buzzing with excitement and curiosity. Question remains, how does this electrolysis process sustain itself? Is the oxygen production significant enough to support complex marine life? And what does this mean for our understanding of life beyond Earth? Researchers are now planning extensive studies to monitor oxygen levels in various deep-sea environments and to explore the potential for similar processes in other regions of the ocean. As we ponder the implications of dark oxygen, we cannot ignore its connection to one of the humanity's oldest questions: how did life begin? The conditions on early Earth were vastly different from what we see today. Volcanic activity, extreme temperature, and a lack of oxygen created a hostile environment. Some scientists believe that life may have originated in deep-sea hydrothermal vents, where mineral-rich water provides the necessary ingredients for life. The discovery of dark oxygen adds another layer to this narrative, suggesting that oxygen production could have occurred in these extreme environments long before photosynthesis evolved. If you have found this exploration of dark oxygen intriguing, don't forget to like, share, and subscribe for more fascinating discoveries from our planet and beyond. Until the next time, keep exploring the wonders of our world. Thank you.